Okay, so this is the second video. So after explaining this, I'm sure you're dying to know what are irrational numbers. Irrational numbers don't include any of this stuff, so what possibly could they be? Well, irrational numbers are numbers that cannot be written in this fraction form. So that's going to be like the number pi. Pi is a number that goes on and on and on without a pattern to it. So that would be an example of an irrational number. What are other examples of irrational numbers? Well, let's see, like 2.36781 ... Here's another decimal that just goes on and on forever without a pattern. So that would be considered irrational. What else would be irrational? Let's say the square root of 6 would be irrational. If you type the square root of 6 into your calculator, second square root 6, you're going to get this decimal that goes on and on and on without a pattern. So this is important to know. Whenever you have square roots that don't just give you one number as its answer, they're called non-perfect square roots. Those are all irrational. So I could literally name an infinite amount of irrational numbers. So another example of a non-perfect square root of 7, square root of 8. These are all irrational numbers. The square root of 9 would not be irrational because the square root of 9 is 3. 3 times 3 is 9. It's a perfect whole number, okay? The square root of 10 would be irrational. And this could just continue on and on and on. So what I'd like you to do now is print or take out this paper, Rational and Irrational Numbers. It's going to be in the folder below. And I want you to just look over these numbers real quick. And in class, we would maybe color the ones that are irrational a different color than the ones that are rational. But maybe just write an I in the box for the ones that you think are irrational. And 1, 2, 3, 4, 5. There's going to be 6 of them on this paper that are irrational. And then I want you to unpause my video and then I'm going to go over them. Okay? All right. Okay, so let's go over the ones that are irrational. So if you're looking at this paper, 5, that's just a regular counting number. Square root of 9 is 3. -4, that's just an integer. 3.2 repeating, that is a decimal that goes on and on forever, but it has a pattern to it. So that is rational. We could actually write that number as a fraction, which I'm going to show you soon, okay? This one, 3.4215553, that one's irrational. So good job if you got that one was irrational. Continues without a pattern. Square root of 32, that is another irrational one. Square root of 32 is not perfect. The square root of 81 is a perfect square. The square root of 81 is 9. 0, that's rational. Pi, we talked about that one. That one is irrational. 12.2, that is rational. That ends. 1/8, we can write that as a fraction. Rational. -22.3, that is rational. Square root of 144. 12 times 12 is 144, so that one is rational. 2 to the 5th power. We would just do 2 times 2 times 2 times 2 times 2, and we would get just a bigger number, and that's just going to be a whole number, so that is rational. Square root of 21, that is not perfect, so that one is irrational. 4.5, that is rational. 1 is rational. Square root of 36 is 6, rational. 2 is rational. 5.320 ... That one doesn't look like it has a pattern to me, so I would call that one irrational. Square root of 100 over 2. So let's look at that one. Square root of 100 is 10. So another way to write this would be 10 over 2, which is equal to 5. That one is rational. 5 is just a regular number. Okay? Square root of 40. That one is the other irrational one because square root of 40 is a decimal that goes on and on. 5 2/5, that's rational because that can be written as a fraction. And then 0.132 repeating, since it's repeating itself, that's rational. We can write that number as a fraction. You'll learn that soon. And then the number 3 is rational. So basically just after looking at this, I want to be able to give you any number and I want you to be able to tell me, is it rational or is it irrational? Okay, next video.